All right, hello class. Today we're going to start off talking about logic. So in this unit, we're going to be converting between some English statements, like an English sentence, and then changing it into a mathematical statement that we can then use to determine the truthfulness of it and that kind of stuff. And so kind of applying a little bit more analytical thinking to the English language. So we have all these symbols over here that you will want to memorize and use. So it's like upside down one. So think about whenever we did intersection, it's kind of similar. It's just like an upside down V instead of that upside down U, like for intersection, but it still means the same thing. So and this one is or. We got this little tilde. It's not, sometimes you're gonna see this as well. So it looks kind of like a little hat. I don't know how to describe it, but that you may also see a symbol that looks like that. This is our if-then statements or our implies, and then this is our if and only if, which is shortened to, if you see IFF, that just is shorthand for if and only if, which basically this means that like the logic goes one way, and then if you see this, it means it's going back and forth, so it's like that and vice versa. This upside down A just means for all, backwards E just means that it exists. So for this one, that means that this exists for all of that argument, for all the x's of that argument, and this one just means that at least one of them works for that argument. And then another one you'll see a bunch is these three dots, and that just means therefore. So this is like if P implies Q and Q implies R, then therefore P implies R. So kind of like our the transitive property if you're thinking of like our mathematical properties. So let's do a little bit of translating. So what's going to happen is you're going to see like a symbol or a sentence like this. So if it is snowing, it is cold. So these are just declarative sentences. So what we're going to do is we're going to translate them into math, basically, into logic. So what we're going to do is the if and then this little comment. So that's going to be that first sentence, that arrow, because it's going in one direction. So we're going to call this if it is snowing. You can label it whatever letters you want. Most of the time you're going to see P, Q, and R most of the time. So I'm going to label this one P. So it is snowing is going to be our first sentence. And then it is cold. We're going to call that Q. And then down here, it is cold is also there. So this is also going to be Q. John is wearing a coat. So John is wearing a coat. We'll call that R. And so if it is snowing, we already said was P. And then therefore John is wearing a coat, so R. So the way that we would write this translated is, so if P, then Q is happening. And so then the next sentence says, if Q, then R is gonna happen. And then we have P. And a lot of times you're gonna see a line after this, and then you're gonna see our three dots for therefore R. And so we'll kind of get more used to this kind of sentence by sentence, this line by line kind of structure, and you'll see this a little bit more in symbolic form. So we'll keep going, doing the same thing. But now what we want to do is translate it, and then we're going to see if it's a valid argument. So for a valid argument, you're going to assume like the if statement is true, and then the then statement will then be a true statement. So then if that is true, then we make like that declarative statement that that is true. And so this ends up being a valid argument. So first thing we want to do is just translate. So let's call the moon is made of cheese. Even if this is not actually true, we said that if that is true, so we're going to assume that this is true. If it is true, then this is also going to be true. So that first sentence is very important. So Mickey is happy, we're going to call that Q. And then it says the moon is made of cheese, so therefore Mickey is happy. So pretty straightforward. So the way that we would translate this is P implies Q, or if P then Q. Then the next sentence is P, and then we draw our line, so our therefore statement is going to be below that, so therefore Q. All right, I'm going to do one more, kind of go through some more examples just so y'all see. So now what we're given these statements. So we're letting P represent it is raining. Q represents Mary is sick. T represents Bob stayed up late last night. R is going to be the capital of France, and S is going to be John as a loudmouth. So going back to those symbols that we had earlier, it says it isn't raining. So it's just a declarative sentence, but it isn't, so that's going to negate it. So you're going to see that little tilde, and then it is raining is P, so that one would be not P. John is loudmouth, but Mary isn't sick. So but is kind of an and, so we're going to do that upside down V, and then Mary isn't sick. It says it isn't sick, so we're going to negate that. So John is a loudmouth, so John is loudmouth is S. So it's going to be S and not, and then Mary is sick is Q. So there's that one, so that's how we translate that. So the next one is Paris is the capital of France, and it is raining, or John is a loudmouth. So Paris is the capital of France, that is R. And then it says, and it is raining. So it is raining is P. And then it says, or John is loudmouth. Remember, or is the thing that looks like a V. And then John is a loudmouth, so that's going to be S. So that's what that one looks like. And then our last one, it is raining if and only if Mary is sick. So it is raining is P. If and only if is the double arrows. I like the double part. You can also just do one line, so kind of like we did with our implies that we were talking about earlier. And then Mary is sick is a Q. So that is how we translate these declarative sentences into arguments.